Okay, here we go. Time to rock and roll. Time to rock and roll with my period 3. Dun, dun, dun. Let's see here. Let's see here. Hey, good morning, Valentina. Good morning, Summer. Oh my gosh, look who's here finally. Preston, where have you been? How you doing? Preston, can you hear me?
Yeah, I can hear you now. I didn't join it yet.
Okay, I think you missed some sessions, haven't you?
I have, but I'm getting caught up.
Okay, are you doing okay?
Yeah, I'm doing okay.
All right, well, I'm glad to see you today. That's good. I'm glad you're back.
How are you?
Oh, well, thanks for asking. I'm doing pretty well, just getting organized here. You know, this is the last week before finals, so it's a big week for everybody. So a lot to do, a lot to get ready for. You guys got your last big week of the first semester next week. And so we got to start the review process here. You guys go to Canvas and print off your mixed review number 1. I also put it up in the chat. Okay, but you got I sent out a message on Remind, and I also put it in Canvas. So it's all over the place, okay? It's here in the chat. I'll put this again. I'll put it back in the chat again one more time, but it's also in Canvas where you guys are going to submit your work. So go ahead and get ready here. You're going to need Desmos to work with here. I'm going to be working with Desmos mostly. Let's see here. Yeah, so get Desmos ready. I'm talking about the graphing calculator and the scientific calculator here, both of them, like we normally use. You could use a TI-84, but I'm going to use the Desmos for everything. So go ahead and print that off, you guys, and look in Canvas. It's called Chapter 1 and 2, Mixed Review, Final Review number 1. Hey, there's Ethan. How we doing, Ethan?
I'm good. How are you?
I'm doing pretty well. Thank you, sir. Good morning, everybody. Let's get ready to rock here. You're going to need Desmos, both graphing calculator and scientific. We're going to use both. And you're going to need your review. If you want to do this all by hand, you can, but it's going to be kind of hard to keep up just because it takes longer to write everything down. So I suggest you do a quick print. Natalie, good morning. Thank you for actually saying good morning to me. I appreciate that. There we go. Rebecca's printing. That's no problem there. So go ahead and get set up here, guys. I'll give you a minute to get that printed off here, and then we will get started. I just came up with a collection of a few problems from chapters 1 and 2 in mixed order. So there's no particular order at all. And a lot of this is calculator based. And if you also have your Z tables and your chapter 1 materials, you might want to get that out handy too. Okay, so chapter 1 and 2. Final covers everything next week. All right, so time to get ready here, guys. Any questions or needs before we get started here? Go ahead and talk to me here. Any questions or needs before we get started with the review? Once again, it's in the chat, and it's also on Canvas, okay? It's at the bottom of the chapter 2 module called Chapters 1 and 2, Mixed Final Review number 1. Hopefully we get more than 23 people. Our attendance has been a little bit low, and this is final prep week, so I suggest you guys show up both days, and also next week we have just 2 sessions before finals. We have 3 more sessions. We have 2 this week, and we have 1 next week, and then our finals. We're going for it. And I can't believe this, but we made it through the first semester after next week. Not done yet by any means, okay? We have to end strong. We have to, do your best. Sonny, I just saw you there. Good morning. How you doing?
What's up?
All right. We'll get your, now, if you can't print for some reason, just take out a piece of graph paper and work with me here. When you're ready, once you have your review printed off and ready to rock, or graph paper, and you got your calculators and your tools ready, go ahead and just type in ready to rock in the chat there. Ethan's ready, Audrey's ready. There we go. Preston, Angela, Shannon, there we go. Chris is ready to rock. Let's do this thing. We're going to start off using Desmos, the graphing version. So type in desmos.com and get this guy, the graphing calculator. We're going to start using this one. I mean, you could use a TI-84, but I think this is the easiest to use. Having a keyboard comes in handy when you do this too as well. I think the 10 keypad on the right side of your keyboard works really well. Instead of using the digital keyboard, you could use the regular keyboard. So I've got a few more people coming in right now, so I'm going to give 1 more minute. Jana, please get ready, and Colson. You guys, I'll put the link in the chat again. This is also, this is also available on Canvas. As you guys know, I uploaded it this morning so you guys could see it and have access to it before class. So always check your Canvas before class. You should do that for all classes. If the teacher, whether it's me or anybody else, puts up a document for the day, which we're using this for the day, for our class session today, then you should get organized. Log in early, see what's going on, see what the teachers have messaged you for any reason. I did. Okay, I started getting ready around 7 o'clock this morning. Well, actually earlier. I got up around 5:30. So I was prepping a few things, getting things ready, and then I posted it around 7 to 7:15 or something like that. Okay, we are going to get started. Looks like a lot of you guys are ready to rock here. So I'm going to start using Desmos, the graphing version, because we're going to enter our data in the scientific calculator, or the graphing calculator here. So this is a mixed review. So there's no particular order, just so you know. I just collected a few problems here that we've done already throughout chapters 1 and 2, and just put them in a random order, and we're just going to get some practice. On Thursday, we'll do review number 2. It'll be a different collection of problems. So, because there's only, I think, 7 problems here, guys. And so on Thursday, it'll be a different review. We'll call it the same title, but number 2. And then if we have another possibility, I think we have another possibility next week before the final, we'll do it again. And just to give you guys as much practice as possible. So if you guys work with me, use your resources, and obviously do a little studying and we'll practice on your own, you should do pretty well. Okay, so I'm just taking a look at it here. So there's only 7 problems in today's short review. Okay, so let's get started here. Any questions or needs before we get started? Because I know a few people just came in late. Matthew, check Canvas. There's also, I also check your chat. I also put the link in the chat for your review. Any questions or needs before we get started? Because I know a lot of you guys are ready. It looks like we're ready. All right, so let's do this here, guys. So the first question here. It goes all the way back to the very beginning of the year when we started talking about mean, median, mode. And these questions are most easily answered in Desmos. So the first thing we're going to do is we're going to read the problem. Okay, so suppose there are following, so these are the following monthly gas expenses throughout the school year. So, you know, yeah, it depends on how much you drive, right? So your gas expenses range. And it's these are monthly, so there better be 12 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. All right, so what we're going to do is go to Desmos first. Go ahead and hit the plus sign. All right, and set up a table. And we're going to put these values on the left side of the table, and so they're X1 values. Okay, and just use your keypad on your keyboard. Okay, so start entering them in and work with me. Every time you hit the enter button, it shifts down, makes it easy for you. So I'm using my keyboard right now. Okay, I'm not the digital keyboard. So 89, 139. Make sure you put those in correctly. I'm going to double check mine when I'm done before we do anything, because if you enter these numbers in wrong, obviously everything will be wrong. All right, so just make sure we'll enter the 12 numbers in, and then we'll double check it, and then we'll go for it. So 68. 65, 74. And this is what I expect you guys to do on your final too. You guys are going to be live with me next week, and you got to perform like this using Desmos, and you got to be quick and you got to be on it because it's going to be timed, and we're not going to go beyond the class period. Okay, so you guys got to be good. So 74, 89, 139, and the last one, 168. So usually what I do is I go up and I check, I count. We're talking about monthly expenses for 1 year, so there better be 12 numbers. So check. I'm gonna just check a few of my values here. So I start at the top and I check. 89, 139, 91, 68. Okay, now as we go through this here, your job, you guys, is to work with me simultaneously. You're going to submit this as soon as we're done. All right, we're going to finish obviously in an hour to hour 15 minutes. There's only 7 questions here, and then we're going to scan it and submit it, and it's due in class. So no goof around and work with me here. And the way I'm going to know you're working with me and doing the right thing is by submitting your work immediately after class. So speak up as we go, ask questions. Okay, now we're ready to calculate the means. Go to row 2. Here we go. This is the Desmos graphing calculator here. We're going to hit that keyboard at the bottom. And then we want to calculate the mean first. So hit functions. All right, stats. We're doing some statistics. So on this menu here, first one's trig, the next one's stats. So hit stats because these are statistics. And you select mean. So now you need to tell the calculator, Desmos, what do you want the mean of? And if you look at the data set up here, these are X1 values. So you type in X1 and then you hit the return button and it says 96.5. Who agrees with that on your end? Because I want you to double check me and everything as well. Because if you enter the wrong numbers in, if I messed up on one of these numbers, then I'm going to have the incorrect result. So give me some kind of response here. Does anybody agree with my mean of 96.5? So Ethan does, Logan, Audrey. Okay. Again, when you do this on your test and your final, before you calculate anything, you double check your data set. Everybody write that down in your paper. Double check data set. You can easily get a question wrong in the final, which would be a bummer, even if you do the right thing. By entering the incorrect data set in. So double check that before you do anything. All right, so let's write these things down as we go. So we got a 96.5 mean. Okay, that's an average or a mean. So the mean here is 96.5. That's an average. Okay, the median. Median is a middle number. After you organize the data, which you don't have to do. I think Desmos has a function called median. So go to row 3, go to functions, select median. All right. Everybody calculate that, type in X1 and then put your answer in the chat. Show me you're working with me here. So let me see, Chris, Rebecca, and Melissa say 87. I'm going to calculate that too. Haven, I'm going to put the link to this document in the chat here one more time for you. Go ahead and click on it, print it, and join us. Good to see you here. Okay, so 87. You guys are saying the mean is 87, so let me type in 87, or the mean of x1, excuse me. All right, I agree with you guys. So we got a mean of 80, a median, excuse me. Sorry, guys, I meant median. So it's 87. Okay, the mode. Now, Desmos doesn't have a mode feature. Just look at the data set. In fact, you know what? Go to the chat. What's the definition? A simple definition of mode. Can you give me some keywords in the chat, please? What's a simple definition of mode? Okay. Okay, I'll go with that. So the most repeated number, the most frequently occurring. Good. So let's write that out. So most frequently occurring, or what you guys what you said is good too. So most frequently occurring number. Okay, can you guys tell me what that is in the list? Are there any repetitions? And if there's more than one repetition, maybe we have more than one mode. I don't know. What do you guys think? What do you think the mode's going to be in this case? So 89. So how many times does 89 repeat? Because now I see two answers here. Do we have one? Okay, so let's highlight them. So 89 repeats, it repeats twice, and then 139 repeats twice. So Natalie said they both repeat twice. So guess what? We have two modes. Okay, so we have two modes. So 89 and 139. Okay, they both repeat twice. Okay, so get some highlighters out too. Get a red pen, a highlighter, and highlight and annotate your problem here. All right, so who just came in? So someone just came in. You guys, if you just came in the class, I just missed it. It's okay. I'm glad to see you, Mateo. So let me put the link to the, sorry, I didn't mean to do that. Okay, so let me go to the chat and then I will put that back in there. So go ahead and click on that, join us, it's on Canvas as well. All right, and I'm using Desmos to do the calculations here. Now the range, now in the functions on Desmos, it doesn't have the range. So what's the definition of range, guys? Let's write it down, it's a simple one. Give me a simple definition, like a mathematical one. How do you calculate the range? Are you guys responding in the chat here? I'm not getting a, okay, so lowest to highest, good. Subtract the highest from the lowest, high minus low. Very good. It's the spread between the smallest and the largest. Hey, nice. Everybody's correct up there. So I like that. So write down high minus low, you know, whatever that is, max minus min. Now, Desmos has a max function and it has a min function. So if you don't want to do this visually, which you can do easily, you can look at the data set and just circle the max and the min. You could use Desmos if you want, I suppose. So you can go max and then x1, which is 168. Okay, if you look at the data set, it's 168. And the lowest is called the min. So you go functions, min. You don't have to do this. It's pretty easy to look at the data set to do this, but I'm just showing you that Desmos can do this or can help you verify. So it's 65. And then so you label 65 in the data set right here. Okay, so here we go. So 168 minus 65, and you get your range right there. So help me out one more time because those definitions were all good. What's your range? What's the spread? What's the high minus low? What's the distance from the lowest to the highest? Chris, are you sure about that? Okay. Maybe we're referencing something else, Chris. I'm not sure. Oh, okay. All right, so 168 minus 65 is 103. It's okay, as long as you understand what happened. That's the important thing. Okay, and then the population standard deviation, underline the word population. So go open up functions, and there's two standard deviations in Desmos. You want the one that ends in a P, this one right here. So let's write it down in the notes. There's two standard deviations, and you do not want to use the wrong one. So use the one ending in a P. So let's write it down in red. So this is Desmos here. So standard ST DEV, and it ends with a P. Okay. And so if you type in X1, you'll notice that you get 31.907. So 31.907. Now in Desmos, there is a variance, but you got to be careful because that's the sample variance. So I wouldn't use Desmos to get the variance because that's a sample variance and not the population variance. So what do you guys remember? How do you go from standard deviation to population variance or to variance? What do you do to 31.907 to get to the variance? Because I don't suggest using Desmos because that's a sample variance and not the population variance. So you'll get the wrong number. Close, but not totally correct. What do you guys do from here to here? From standard deviation to variance? Come on, take a shot at it. What do you guys think you do? I like that boldness, Natalie. Very good. Let's write down square it. Okay, so square it. So you got to take 31.909, excuse me, 31.907 and square it. So let's do that. So go to the next row and just type it in. All right, so 31.907 and then go a squared. And then you get about 1,018.06 roughly. So 1,018.06. Okay. And then make a little note to yourself. Do not use Desmos in the variance button because that's sample variance in Desmos, not population variance. It's different. There's a difference between using the entire population of numbers versus only a subset of that called a sample, which we're not doing. Okay. All right, so we've got number one here. Any, before we transition here to number two, any questions on A through F there on number one? And if not, give me some kind of emoji on the screen or response in the chat. Because most of you guys have your videos off, so I can't see you guys. So talk to me here. Thank you, Matthew, Logan, and Chris. Garrett, okay, Connor. Okay, Tristan, there we go. Okay, very good. Let's transition to number two. Okay, so number two, like I said, this is a mixed review. So these are in no particular order, and your finals like that too, by the way. So it's just a collection of problems that we've studied before. Okay, so we want to annotate first. So let's get out our red pen and let's write down what we know. So Haven here has a deposit's 14 grand, 14,000. So that's principal, 14,000. So right here, the principal that she deposits is 14,000, and the account yields 3.2% interest compounded quarterly. Quarterly, and the interest rate right here, R is equal to 0.032 quarterly, and equals 4. See how we annotate and write down what you know about the problem. There was 4 quarters per year, so n equals 4. The interest rate is 3.2%, so divided by 100, you get 0.032. And it says, how long will it take her balance to become 24,000? And that's the future value. Okay. Now, one of the things that you're going to need to do is have all your formulas handy for chapters 1 and 2. You're going to have your z-tables, your empirical numbers, all your formulas from chapter 2, all organized on before you get to the final. And so there's going to be some research needed, and you're going to have all chapter 1 and chapter 2 materials and notes ready and get really organized, because you have an hour and a half only, and then we take our assessment, and then we're done on finals week. So you have to get organized. So make notes right now on things that you need to get ready. Formula sheet, z-tables. I mean, get your resources out and ready, okay? So we have to set up an equation here. So here we go. Let's set it up. So let's see here, we got 24,000. So, let's see. Can someone go to the chat here and just tell me what the setup is? How do you set this up? Or turn your mic on and just say it out loud and I'll write it down. I need a bold, brave person to just help me out here, because we're just reviewing what we did in chapter 2. Anybody want to give it a shot here? Need a bold, brave, courageous, young financial mathematician. Yeah. Okay, so Chris, there you go. Yeah, and then the one inside the parentheses, that equal sign, just make it a plus sign, but you got it. Okay, so let's use that. All right, so you got it, Chris. So here we go. So let's take 24,000. Here we go. So 24,000. See right there, that shows me that he knows his formulas right there. So 24,000 is going to be equal to the principal, which is 14,000, times 1 plus the R divided by N. So R is 0.032 divided by N, which is 4, because there's 4 quarters per year, raised to the NT power. Now it says N is 4, and it says how long? How long? Well, we don't know how long. This T is unknown. Okay, so it's going to be to the 4T power. So we're solving for T here in the exponent. So everybody, give me a quick response. What does this equation call for? What does it require to be solved? Yes, okay, we'll get to that in a minute. Very good, you guys. Very good. Okay, so let's divide by 14,000 first. Let's simplify a little bit. Okay, so we have, cancel out the leading zeros here. So 1, 2, 3. So we get 24 14ths. If you want to simplify that further to 12 sevenths, you may. Okay, it doesn't really matter because we're going to use the calculator here in a minute. And that's going to be equal to 1 plus 0.032 divided by 4 to the 4T power. Now I'm going to switch calculators now. I'm going to go to the scientific. So look at my screen, type in desmos.com/scientific. On your final next week, you guys, you're going to need to have both handy. So before you get to the final, you got to have your formula resources ready. You got to have your z-tables, you got to have all your notes, and you got to be organized. You also have to have a couple tabs open, one for the graphing calculator, one for the scientific. So open up desmos.com/scientific. I have them on favorites buttons at the top. So I just do a one click. And if you haven't organized your browser like that, put them at the very top. Let me show you what I'm talking about. They're at the very top of the screen here. Desmos Graphing, Desmos Scientific. Then I've got my classes P1 through P6. I got my Gmail button. I mean, I got all organized here. So all I have to do is just click on one of them and I'm good to go. You need to get, if you haven't done that, you need to get organized. Now let's solve this together here. So here we go. We got to take the log of both sides. So let's just use the common log. So here we go. So I'm just going to take the log of the left side, which is 24/14. I'm going to take the log of the right side, which is, oh, by the way, stop right here. The 0.032, watch on Desmos. 0.032 divided by 4 is 0.008. It's not repeating. And when it's not repeating, you can write it, the inside of the parentheses, you can write it as 1.008 because 1 plus 0.008 is 1.008, which is easier to write. So let's write it that way. See? Looks easier to handle right there. So now give me some suggestions. Here we are on the equation right here. So what do? What did you guys learn in chapter 2 about solving log equations or equations dealing with logarithms? What's that log property that we need to use right now? Okay, very good. We're using that exponent property. We want to shift the exponent. Let me get my red pen out here. We want to shift the exponent to the front of the log. So shift exponent. All right, to front of log. Okay, that was an exponent property that we learned. All right, so we're going to do that. We're using the log properties. There you go. Everybody's correct in the chat there. Kayla, does that make sense what I'm saying? Because I think, I don't think you were here at this point. So take detailed notes that all that stuff I haven't read up there, okay? So let me see. We take the log of 24/14. Like I said, you don't have to simplify it because the calculator is going to do all the work anyways. And we're going to shift 4t in the front. So it's going to be 4t times the log 1.008. Okay, so there we go. Now we solve for t. To do that, I got to divide by 4. I also have to divide by the log of 1.008 on both sides. Okay, so what's t? Go ahead and do that. There we go. Put your answer in the chat. Round it to nearest 10th is good because we're talking about the number of years here, how long it will take to go from 14,000 to 24,000 at that interest rate. And so just round it to the nearest 10th of a year. Shannon saying 16.9 years. Rebecca agrees. What do you guys think? Go ahead and make the calculation on Desmos. So function, log, and you start typing it in Desmos. You use the scientific version now. Make sure you use parentheses correctly. And if you have any calculator issues, make sure you speak up because getting good at the calculator is obviously really important. Okay, and then let me see astro degrees too. So 4 times the log, okay, the log of 1.008. And you know, Desmos, what's cool about it is that it looks identical to what you have on your paper too. So about 16.9 years. And let's make sure you understand that t in these equations are always a number of years. So make a note of that on your paper there. T is a number of years, not months, days, whatnot. It's always a number of years. Okay. Now going back in time to chapter 1 again. Here we go. Let's transition to number 3. Suppose the test scores of senior class of 700 students is normally distributed, okay? A normal distribution, and it has a mean of 54. So let's highlight that, and a standard deviation of 3. So we know a couple things. We know the mean is 54. We know the standard deviation, which is sigma, which is equal to 3. The very first thing we need to do is draw the normal distribution as a bell curve. And we're going to be using the empirical rule. So highlight that. We're going to be using the empirical rule, which is an approximation method, not an exact method, or a more accurate method of using the z-tables. Empirical rule just lets you do things or calculate things, probabilities, without the z-table if you didn't have that handy, which most people don't. All right, so most people don't carry around a z-table, at least I don't. So even though I'm a math guy. So let's draw the bell curve, a normal bell curve. And this is where your resources have to come in. You're going to have to get organized this week. You're going to have to get out your notes on the empirical rule, get out your notes on the z-tables, get out your form. I mean, get everything out and have it really organized, because on finals day, you cannot spend and waste time go searching for stuff. One of the biggest mistakes people make is they don't come prepared to a test. So you have to have all your resources. So make some mental notes, write some things down for you guys to do and get organized later on today. This will help you also for your Thursday session. Okay, so help me out a little bit here. What goes in the middle? Right here. What goes in the middle of the bell curve? What splits it right down the middle? Okay, so yeah, the mean. Very good, Rebecca. So the mean is 54. So the mean mu, okay, which is 54. Now let's talk about, we got a standard deviation of 3. So we have to list out 3 deviations to the right. So z equals 1, z equals 2, and z equals 3. So let's go 3 deviations to the right. So if you're greater than the mean, you're going to be positive z-score. If you're less than the mean, you're going to have a negative z-score. So 57, 60, 63. So go 3 standard deviations to the right. And make a little note to yourself. I'm trying to give you guys and recalling, because we haven't done this in a couple months. So positive z-scores are to the right all the time if you're greater than the mean. If you're less than the mean, the z-scores are going to be negative. So again, write some mental notes down. So when you go to the left of the mean, you're at z equals -1. It has a negative z-score. And then the second deviation to the left is z equals -2. And the third one, it corresponds to z equals -3. So 54 minus 3 is 51, minus 3 is 48, minus 3 is 45. Now, to be quick on the final, you have all this stuff written down in your notes. So it's really going to be really important that you get your notes out on the empirical rule. You get your notes out on the z-scores and all that, the z-tables, and you have that ready to rock. And you can use it effectively. So there's 3 regions here. So let's talk about the percentages. Now, the empirical rule goes like this. So let's write it down in red. The empirical rule is 68, 95, 99.7 rule. So 68% lives in this yellow region. So if you divide 68 by 2, what do you get? Let's put the percentages in here. What's 68 divided by 2? So if you remember the name of the empirical rule, which is the 68, 95, 99.7 rule, then you can put the percentages in, which is how I led this discussion a couple months ago. Okay, very good. So now this is 34%, 34%. If you have highlighters, start using them, okay? So let's see here. So now there's 95% of the data live in here. Okay, so 68 from 95, and then we got to divide that by 2. What is that? So let's just go to decimal. So it's 95 minus 68. So 95 minus 68. Okay, notice that's 27, and then you got to take half divided by 2. Look at this. This is how I calculated. Oops, I got to type it incorrectly here. Sorry. And then so 27. Look at this. 27 divided by 2. Okay, you know what that is. It's 13.5. So, and these other ones, the next two columns, this is 13.5 and this is 13.5. That's how I developed it in the very beginning. Okay, and again, if you just take out your notes, you don't have to recreate this. Okay, you just use it. So it's important that you find your notes. And then this next region here in green, let's say there's 97%, 99.7%. It lies in that green region, which means, okay, this little region in through here, it's actually smaller than that, but it's close enough. That's 2.35%. And this last region, very, very small, it's 0.15%. So I'm just going over the basic percentages so we can start using the empirical rule here. So when you do this, you got to have these tables handy so that all you have to do is use them, because you shouldn't have to recreate the wheel every single time unless you have to, but you don't have to because it's open note. Okay, it's an open note test because we're online these days. So you get to use all your resources. Okay, so here we go. Now, since we have all the percentages in here, so let's use it. So it says use the empirical rule to determine the percentage of students that are between 48 and 57. 48 and 57, right through here. Okay, so what would that be? What numbers do we have to add up in the diagram, in the bell curve? What percentages do we have to add up? Can you guys tell me what those are? To get the probability that the percentage of students, or the probability that students are between 48 and 57. Okay, that's one way to do it. There you go. So you can add up 13.5 plus 68, and 68 is the 34 plus 34. So let's do that. So the probability that you're between those values is 13.5% plus the 34% plus the 34, which Rebecca said was 68. So what is that, you guys? Go ahead and add them up. What's 68 plus 13.5.5? Okay, so there we go. Very good. So 81.5% of the students were between 48 and 57. Okay. All right. Next question here. Use the empirical rule again. Again, this is the empirical rule questions, which is just an approximation method. All right, to determine the percentage who scored less than or equal to 51. Okay, so that is, here's 51 on the table, and you got to go less than or equal to 51. There's a couple ways to do this. Can someone give me one of two ways? Okay, there's two ways to calculate this number here. If you're less than or equal to a score of 51, how would you calculate? Give me a method up there. What numbers do you add in the table to get the percentage of students that are less than or equal to 51? Or, okay, now Chris, good. That's one way to do it. So let's do that. So method one is equal to 0.15% plus 2.35% plus the 13.5%. That's one way to do it. You guys can jump in here. What does that equal to? If you're, we've got to get a total there. And then I need a second method here. What's the other way to do it? Close. There you go. Okay, so that's 16%. What's the other way to calculate this? Because that's to the left of 51. How do you use the numbers to the right? Remember, the entire bell curve is 100%. Remember that. So you got to subtract what? What from what? What percentage is to the right of 51 or greater than 51? So that's Close, Chris. Goes not 100 minus 16, but 100 minus, what's the percentage greater than 51 to the right of it? Well, Rebecca, you want to go all the way, the entire curve. Remember, the entire curve is 100 represents. So okay, so to the right, there we go. To the right of 51 is 50 plus 34 or 84%. Now, what do we do with 84% to get to 16%, which is our answer? Remember, the entire curve represents 100% of the scores. The area underneath the curve is 100%. So if to the right is 84 and you want to get to the left, now there you go, Garrett. There we go. Okay, so method 2 was to take the entire probability, which is 100%, minus the probability on the right of it, which is 84%, which gives you a total of 16%. So either way, one validates the other. It's just two ways to get the same number. All right. And again, it's important to review, okay? Just because we did something 2 or 3 months ago doesn't mean you have it all, in your back in your memory again. So reviewing for a final in any class, I don't care what class it is, takes practice. Okay, let's go to the next question, question 4. Okay, so this one's different. Again, this is a mixed review. It's just jumping around in chapters 1 and 2. Okay, so here we go. Shannon deposits $15,000 into an account that yields 5.2%, 5.25%. So there's your interest rate. So let's write down what we know, as I always do. Okay, so R right here, R is 0.0525. She deposits this, so this is the principal. It's compounded continuously. Ooh, okay. How long will it take? How long? T equals question mark. How long will it take for a balance to get to $25,000? That's your future balance. Okay, go to the chat, everybody. What's the equation we use? This is compounding continuously, not quarterly, not monthly, not daily. Very good, Audrey. Very good. Let's write it down. So the future balance is equal to the principal times e to the RT power. Highlight the word continuously. This is what I'm saying. You guys got to get really organized, have your formula sheets handy, z-tables, empirical work, all that kind of stuff. All the important things that you guys don't have memorized, you have to have organized. And again, it's open note test. So the better organized you get, the faster you're going to be, and the more likely you guys are going to be successful on the final, because you want to do well. You want to get an A on the final, A or a B. Okay. So let's start putting some numbers in. So 25,000 is equal to 15,000 times e to the RT power. So 0.0525 times t. Okay, what do you guys suggest first? What should we do to solve for t, the number of years it takes to get from 15,000 to 25,000? What's our first step?
Mr. Aynesworth?
Yeah.
On question 3, parts B and C, you skipped the second part of the question.
I did?
Because it said how many students does it represent?
Oh yeah, we're not done yet. Okay. Thank you. Let's go back to number 3 before we finish number 4. Yeah, because I gotta read the second parts of the question. Aha! Okay, thank you. So pause, everybody. I was jumping the gun here, which is not good. So let's go back to 3B, and let's answer the second part of the question. How many students does this represent? Because 81.5 is a percentage, not a number. And there were 700 students. So this is a 700 student problem. So 700 students total. So can someone help me out? How many out of the 700 are are there between 48 and 57, or score 48 and 57? How do we calculate that? What do we do? There we go. Good job, Chris. Okay. Well, wait a minute. You're on, that's part C. So Chris, do you write that down for part C? So we'll do part C as well. So here, 700 times 0.16 will give us the number of students in part C. That's what Chris just put up there. And then in part B, we need to take 81.5% of 700. So that's 0.815 times 700. So let's do both of these and let's finish strong here, because I was going a little bit too fast right there. Can someone help me out with 7B? Okay, what's 81.5% of 700? Roughly, round it down to the nearest student too, by the way. What are you guys coming up with? What's 0.815 times 700 rounded down? Who agrees with Rebecca there? I need some confirmation here, guys. We're calculating 81.5% of 700. You can round it down. That's fine. Let's see. Let me calculate it too, because I haven't done it yet. So 0.815 times 700. Yeah. So I know 0.5. I know the rounding rule is going up, but if you round it down, it rounds down to 570 students roughly. Okay, because again, these are approximations. These are not exact by any means. So about 570 students. Okay, I'll put approximately equal to here. And then the next one here, what's 16%? So 700, okay. What's 700 or 16% of 700 roughly? Okay, you guys are saying 112. Okay, so let's do that. Yeah, okay, so there you go. It's about 112 students. Okay. So I forgot who enlightened me that we need to do part B, the second part of those, but thank you, whoever brought that to my attention. Okay, so going back to number 4. How do we solve this? Here we go, help me out. Rebecca, Valentina, thank you. So how do we solve this? What's our first step? Can you guys give me some steps here? Talk to me, as they say. All right, so it'd be nice if a lot more people get involved in the chat, especially those people that do not have your videos on. Show me that you're there by participating. Grant, Angela, Alyssa, everybody, okay, just get involved. Tyler, Cameron, Matthew, get involved in the chat, okay, get involved in questioning, okay, because if you don't and you're not doing the right thing behind the computer screen, well, you're not going to do well. So which is not something I want to see. I want to see you guys be successful. Okay, so let's divide by 15,000. Okay, simplify. So I see 25/15ths on the right. And that's equal to e to the power of 0.0525t. Now what? We're trying to solve for the amount of time, the number of years it takes to get from 15,000 to 25,000 at that interest rate, if it's compounded continuously. So what do? Okay, let's take the natural log then. Okay, so take the natural log of the left side. Take the natural log of the right side. All right, now let's kick in that exponent rule again. So now we're in log form. And as soon as you're in log form, you shift that exponent to the front of the log, okay? Use that main property of logarithms to your advantage. Okay, so let's do that. We're going to take the log of the left side, the natural log, excuse me, of 25/15ths, and that's going to be equal to 0.0525 t times the natural log of e. Tyler, is everything okay with you? Talk to me, Tyler. Are you okay? Oh boy. Okay. What's going on here? Rebecca, can you still hear me okay? You can? Okay, just making sure.
I can hear you.
Okay, because Tyler's not responding and we're just double checking things here. Okay, so go to the chat real quick, guys. Tell me what the natural log of e is. What do you remember about that? What is the natural log of e? Hey, Tyler, you're there. Okay, why didn't you respond, buddy? You always respond to me.
I keep getting kicked out. Like the screen just keeps saying, like reconnecting. I don't know why.
Okay. All right. Well, I'm glad you made it back in.
Thank you.
Okay. So this is equal to 1 here. So all we have to do is divide by the decimal. And let's get t. Okay. Go to Desmos, you guys, and input your values. And let's figure out the number of years it takes to go from 15,000 to 25,000. Shannon says 9.7 years. I just need some confirmation on that because I haven't done it yet either. What do you guys think? Rebecca agrees with Shannon. And Kayla agrees. Okay. And Astrid too. Okay. Ooh, Preston really agrees. Okay. I agree too. So I came up with 9.7 as well. All right, here we go. Now let's go back in time again. Let's start using z-tables. And as I said multiple times already during the session here, you guys have to get organized, which means you got to find your z-tables. Okay, so if you don't have them with you right now, it's okay. I'm going to display it, but you need them on your own when you're taking your exam. Okay, so no, we're not using the empirical rule anymore. We're using z-tables here, which gives slightly different answers, a little bit more accurate. Suppose we have a normal distribution. So let's, again, highlight the important words. We have a mean of 64, and we have a standard deviation of 3. So this is what we know. The first thing we do is we draw the bell curve, and then we draw the normal bell curve. So let's do that first, as we always do. Let's put the mean right in the middle of 64. There's your mean, mu. Okay, and remember, z-scores that are positive are to the right. Okay, if you're greater than the mean, then you are to the right of the z-scores are always positive. So let's go to the right first. Okay, so let's go 3 standard deviations to the right. So 67, 70, 73. So z equals 1, z equals 2, z equals 3. Now, we don't have to put the percentages in like the last problem because we're not using the empirical rule. We're going to get all our probabilities from the table, the z table. So I'm going to show the z table here in a minute. Okay, and then let's go to the left. Z-scores that are less than the mean are negative. So subtract 3 and go to the left. So 64 minus 3 is 61. And then 58. And then 55. So this corresponds to Z equals -1, Z equals -2, Z equals -3. So remember, Z-scores that are negative are less than the mean. If you're less than the mean, if you're greater than the mean, you're positive. So positive to the right, negative to the left. Make notes of that on your paper just to remind yourself. So let's go through 2 basic probabilities and let's kick in your Z-tables here and do a little practice because we haven't done this in a couple months. Okay, so there's 3 basic questions that can be asked that we studied. The first basic one is finding the probability that you're less than 61. So what is that probability? So what we want to do is figure out the Z-score first, because notice that 61's is in the diagram, it's in the Z-table. But most of the time when you're using Z-tables, you know, the score that I'm asking for, if I ask for 60, it's not going to be in the diagram. So let's calculate the Z-score. So let's write down our formula that we used to use. So Z is, and put this in red too, put all the formulas in red. So Z, to calculate any Z value, it's always the score, okay, X is the score, minus the mean divided by the standard deviation. This is the score. And this is the mean. And this is the standard deviation. So score minus mean divided by standard deviation. That's how you calculate any Z-score. And that should be on your formula page. So when you guys get organized tonight and tomorrow, because I want you to get organized before Thursday when we do our second review session, I want you to get all your materials ready and get organized. Make a formula page with everything from chapter 1 and 2 on it, so you only have to look at one page. All right, the more organized you get, the better. Okay, the better and faster you're going to be. So let's put in the numbers here. So the score is 61. So it's going to be 61, all right, minus the mean. Mean up here is 64, divided by the standard deviation, which is 3. It says so up here at the top. So divided by 3. Now, if you take 61 minus 64, you get -3. You don't need a calculator on this one. Divided by 3 gives you -1, which makes sense. On the diagram, if you look at 61, you go straight up, okay? That corresponds to a Z-score of -1. Now on the test, it may be like something like 60. So it could be between -1 and -2. So you have to just go with the flow. But the diagram tells you that you're on the right track. Okay, now let's use the Z-table. So when I was teaching this, I did something like this. So let's draw a little diagram. I put Z in the upper left-hand corner. And -1 is the same thing as -1.0. So on the vertical, you're looking for -1 on the Z-table. And then 0.0, so 0.0, because -1 is the same thing as -1.0. Because there's no tenths place, it's 0. And then on the table, when you need to look, you look down and then you look right here and you get that probability, whatever that may be. So let's go to the Z-table and find the negative side of the Z-table and find that probability. So this is what we used before. So let me erase some of the work that we did before. Here's the negative side of the Z-table. So everybody look at your screen, especially if you don't have your Z-tables in front of you. Okay, then look at the screen. Here's -1. Here's 0.0 here. This is, these are in the hundreds up top on the vertical. So you look down and you look right, and there's your probability right there. That's less than. This probability represents the probability that you're less than or less than or equal to the score. So 0.1587 roughly, 0.1587. So let's bring that in. So 0.1587, which corresponds to 15.87%. Okay, and again, any probability in the table represents less than or to the left of the score. So left or less than the score. So if you have to get a probability to the right of the score or greater than the score, you're going to have to subtract it from 100. So you got to remember that all these probabilities in your z-tables represent values that are less than or to the left of the score, not to the right. So this probability, our final result, the probability that the score is less than 61 is equal to roughly 15.87%. That's the final answer on this one. So I'm talking about this area here in the curve. So if you use the empirical rule on that, it would be close to that. In fact, if you use the empirical rule, it would be 16%. And 15.8% or 15.87% is very close to 16, as you guys know, if you just round up. Okay, it's been a while. It's probably been a couple, at least 2 months since we've done this. Are we all good so far? Give me some feedback right now. I see Rebecca, but I don't see everybody else. How are we doing out there? Now I'm looking at the screen and the chat at the same time here, just to give you to see what's going on with you guys. Okay, if there are any specific questions, you guys got to speak up. Remember, this is just review. Now the other basic question that I could ask, okay, is something like this. So what's the probability that it's at least? At least means greater than or equal to. So these keywords here represent greater than or equal to. So if you're, what's the probability that you're greater than or equal to 68? Okay, or at least 68. That means 68 or higher. That's what it means. Okay, so what we need to do is calculate the z-score first, because 68, look at the table. 68 is between 67 and 70. It's let's put it in there. 68's in here somewhere. So we got to have a z-score between 1 and 2. It's not z equal 1. It's not z equal 2. It's between 1 and 2. So the z-score better be 1 point something. So even before you calculate, you should predict in your mind, use your noggin up here, what it's got to be. Because, good mathematicians do that. So z, what's z equal to? So z is equal to the score minus the mean divided by sigma, which is your standard deviation. So here we go again. Notice that I wrote the formula again. So you take the score of 68 minus our mean divided by 3, which is your standard deviation. Let's calculate that. In fact, go ahead and do that on Desmos and then tell me what the z value is. And I want the first 3 digits of it, because you're going to need the first 3 digits in your table. Very good. So 4/3 is about 1.3 repeating, so 1.33. Write down a little note to yourself. You want the first 3 digits, okay, when you're using the z-table. So now speaking of the z-table, let's do it. So let's draw a little diagram for the z-table. Now 1.33, just so you know, is 1.3, all right, plus 0.03. That's the same thing. So on the z-table, you look for 1.3 on the vertical and then 0.03 on the horizontal. And then you find this probability in your table. That right there is really, really important. In the beginning, when we were first covering this and first learning this material, that right there was a stumbling block for some people. 1.33 is the same thing as 1.3 plus 0.03. So the hundredths place goes on the horizontal and the first 2 digits go on the vertical, always, for any z-score. Now let's go to the z-table on the positive side and let's find 1.33. So this is negative, so you got to go to the positive one. Holy cow, we did a lot of practice. Look at this. Okay, so let me erase this stuff here. Okay, so we find 1.3 on the vertical, 0.03 on the horizontal here, and then you go down and to the right. And then you look at that number there. Take a look closely here. And you want the first, at least the first 3-4 digits. So 0.9082. So So 0.9082, which corresponds to 90.82%. Now this number here in the table represents the score that's less than 68. Less than 68. Remember that. It's always less than or to the left, but we want a probability to the right. So what do? What's your common sense say? If 90.82% of all the scores are less than 68, but we want at least 68 or 68. Okay, good, Chris. That's one way to do it. All right. So 1 minus that. Go ahead and tell me what that is, Chris. So his 1 represents 100. His 0.9802 is 98.02%. So go ahead and subtract, Chris, and what do you get? Okay, and then we just convert that to percentage. So what's that as a percent? Wait a minute, what? Oh, you know, you got your digits a little backwards. I'm sorry. I didn't notice that until now. So I think the digits backwards. Let me check the Z table again. 0.908. Yeah, you wrote 0.98. Switch your digits a little bit and then you got it. Okay, but your process is perfect. Okay, so we want the probability to the right. So the probability that you're greater than 68% is equal to 100%, or 1 as he put it, okay, minus 90.82%, which is a little over 9%. Chris, your method is all correct. Okay, so just change your digits and you got it. No big deal. So that happens to me all the time. I'm dyslexic and I get my digits backwards too. So 100 minus, all right, 90.82 gives you 9.18%, as Astrid was saying up there in the chat. Okay, so 9.18%. Okay, so 9.18%, a little over 9% of all the scores are going to be greater than 68. About 91% is less than 68. Okay, how we doing on that, guys? All right, thanks for giving me some feedback up there. Okay. All right, so let's move on. Okay, last few questions of the review. Now, I think I updated the file that I put on Canvas, and someone confirmed this. I wanted to change from quarterly to monthly. Does it say compounding monthly on your review? Okay, very good. So I was just making sure that I updated it. So let's go for it. So J-Ron here invests $5,000 in an account that pays 6.5% annual interest rate, compounded monthly. So the fact that it's monthly is important, n equals 12, because there's obviously 12 months in a year. R right here, so this value, R is 0.065 as a decimal. You always divide it by 100 and write it as a decimal. And then it says calculate the ending balance. Okay, I don't know what that is. So what is the future balance after 4 years? So T equals 4. So once you determine what you know the principal is equal to 5,000. You don't know what the ending balance is. You kind of have a feel of what's going on. And then you want to set it up. So how do you set this up? So B is equal to what? You guys tell me in the chat. How do you set this one up? Write it down first on your paper and then go ahead and type it in, because you can, believe it or not, you can type all these things in pretty easily on your keyboard. Or just turn your mic on. You can just tell me what it is. Either one. But get involved, okay? Write it down first, and then let's Let's compare setup because that's the critical thing. That's the we're compounding. So you don't use the simple interest formula. That will be on the next review on Thursday. Go compounding. We need a compounding formula. So use that more complicated one. But so can someone put the numbers in? Okay, here we go. Yeah, it just took a while to type. And notice that Chris's exponent. You guys agree with Chris's exponent of 48? Why is it? There we go. Okay, so notice what the students are saying right here. Shannon said 12 times 4, 48. It's always to the nt power. So very good. Let's put it all together. So here we go. So 5,000 times 1 plus 0.065 divided by 12 raised to the 48th power because there's 48 months in 4 years. All right. Go ahead and calculate that on Desmos. And then this is money, so you're going to have to round it to the nearest penny or nearest hundredth. Always, when anything deals with money, financial currency, you always round to the nearest hundredth because there's obviously 100 pennies in a dollar. So how much money would J-Ron have after 4 years at that interest rate? Shannon and Rebecca say the same, and Alyssa agrees. Okay, let me just calculate that too. So 5,000 times 1 plus, then the 0.065 raised. Oh, I forgot. Ooh, got to divide that by 12. And then got to raise that to the 48th power. Good thing we have calculators these days. That would really suck to do it by hand. Okay, that'd be really complicated. I don't care who you are. So $6,480.10 rounded. Okay, very good. Good job, you guys. Okay, last question of the review. So Shannon here opened up an account at Schools First, which is my credit union. By depositing 300, the account pays 3.25%. So there's your interest rate. R is 0.0325. And it's compounded monthly right there. So N equals 12. So it says she deposits 300 every month. Let's stop right there. You guys, this goes out to the class. Is this a single deposit situation or a periodic deposit? Okay, so let's make a note of that. Periodic deposit. So we don't use the equation that we use right above, okay? This is single deposit. Up here, this is a periodic deposit, which calls for a different formula. So she's going to do this for 5 years. The question is how much will she have at the end of the 5-year period? So I'm just going to write it down because this is too complicated to put in the chat. So principal, or the periodic deposit P, times the quantity 1 plus R divided by N to the NT power minus 1, all divided by R divided by N. This is for a periodic deposit. So one thing that's critical on your final, because it's a mixed question type final, is that you're going to have to look at all the keywords and interpret and really, really get organized. You're going to have a formula sheet that has all the critical features on it, Z tables, your empirical rule table, and just have all your ducks in a row and get really organized to be successful, because you don't have time to goof around and to do research. The research has to be done during the review process this week to get ready for next week. So let's calculate what she'll have it after a 5-year period. So she's going to invest 300 monthly. So start off with 300. times, notice the double parentheses here, 1 plus 0.0325 divided by 12, because we're doing it monthly, raised to what power? What power should we raise that to? Let me highlight it right here. What power? How many months in 5 years? Very good, you guys. So 5 times 12. 5 times 12 equals 60 months. So 60th power right there. And then subtract 1. Make sure you minus the 1 there, because you forget that, then nothing's going to come out, right? And then you divide it by 0.0325 divided by 12. Go ahead and go to Desmos now, enter it in, and see what you get. If you're on the T84, be careful with your parentheses. On the T84, I'm pretty sure that you have to put parentheses around the denominator. On Desmos, a little bit easier. Does anybody agree with Rebecca's result? 19,516 bucks, 42 cents. Not bad for $300 every month for only 5 years. Let me know if you agree, or if you disagree, put up your number. I need a few more students to confirm or disagree, one of the two. Astrid, Chris, Audrey. Okay, so most of you guys are coming up with the same. Let me just double check this number here. So I'm going to enter in 300. I'm going to go double up on the left parentheses there. Notice that 1 plus 0.0325 divided by 12. You got to get out of the denominator by using the right arrow key on Desmos. And then you got to close off the parentheses before you raise it to the power of 60. And then you got to get out of the exponent before you subtract 1. And then you divide it by 0.0325 divided by 12. And look at that. I agree with you guys. So, okay. So $19,516.42. That if you deposit 300 monthly for 5 years straight, that's what you will have at that interest rate, assuming. If the interest rate was higher, then you'd have more money. If the interest rate was lower, then you would have less money, but not bad. That'd be a nice little nest egg, by the way, for you guys to have when you graduate college. So you can do this thing for 4 years and save all through college for 4 years straight, have a nest egg, that's what they call it, and then you can buy your first condo. Okay, you can down payment on your condo instead of renting and wasting your money. You can actually start investing in yourself by getting either a condo or a small townhome or something like that, something affordable. I've been trying to get my son to do that. Save, stay home as long as possible, save your money, and instead of renting, you put a down payment on a house. Much more cost effective. Okay, there we go. That's review number 1. On Thursday, we'll do another one before your final. And remember, it's so important, make notes. You guys have got to get your formulas down, get organized, have all your resources. And hopefully you heard me say that like almost 10 times today. So get really organized. And then on Thursday, you should be faster. It should be a little bit better. I'll pick different problems and each time, and then we'll just practice and get a lot of practice experience. Any questions or needs before I let you go today? Well, look at this. We got 33 people. That's a good turnout today, much better than before. Again, this is prep week for finals, just dialing things in. And right now in Canvas, let me open that up. Let me just make sure it should be open for you guys, but let me double check. Hopefully I published it here. At the bottom of chapter 2. Oh, shoot. I didn't publish it. Okay, everybody refresh your browser right now. I forgot to hit the publish button. I apologize. That was a mistake. Okay, this is where you're going to be submitting your work right now. So all you have to do, Sonny, just go ahead and plug it in, plug your Chromebook in, and then, because you got to take your pictures of your work and submit it right here. Do you guys see it on your end?
Yeah.
Okay, so make sure you refresh your browser so you see it's published. Go ahead and just scan your work right now, submit it, and you're good to go. And then all you have to do is get organized for Thursday, meaning get all your, you got to do a little organization here, get all your stuff ready, and then I'll see you on Thursday. Okay, guys? All right, Natalie, have a good day. Everybody have a good day. It was good working with you guys. Good job. I'm proud of you guys.
Thank you.
See you, Audrey. See you, Chris. Everybody. See you, Ethan. Have a good day, bud.
Mr. Ains,
Yes.
it might just be me, I don't know, but I don't see a submit button for the
Me too. I don't know.
next
Oh,
one.
oh, you know why? Because I just noticed that I didn't press one key little button. Okay, so,
Yeah, I just wanted to make sure.
oh no, I'm glad you brought that up. So hang on, don't leave yet. Let me just make sure I said it correctly here. I forgot to hit the submit button. Yep. Okay. Now refresh your browser and now will it let you?
Yeah, we're all good.
All right. Thanks for letting me know.
All
I
right.
appreciate that.
Have a good one, Mr. Ains.
All right. See you, Ethan.
Thank you.
Aaliyah, where are you? Dun, dun, dun. Need to stick around there, Tiger.